Viti, read first question.
How does the electric flux due to a point charge enclosed by a spherical Gaussian surface get affected when its radius is increased?
Okay. That means whether the flux which is charged inside upon epsilon naught increases or decreases when we increase the radius of this sphere. Will there be any change when you increase the radius of sphere? No change, because flux is nothing but charge enclosed. So whether you have small sphere, larger sphere, still larger sphere, still larger sphere, will there be any change?
No.
So can I write answer like this? By Gauss's theorem, flux phi is equals to charge inside upon epsilon. Therefore, increasing radius has no effect on flux. Write this answer. Increasing radius has no effect on flux. Increasing radius has no effect on the flux. Second question. What is electric flux? This one done?
Yes, sir.
What is electric flux? See, I have posted question on the common group. So please go through it so that we can save the time and I can complete the revision faster. What is electric flux through a cube of side 1 which encloses electric dipole? These are all MCQ questions only written in the form of one-liner answers. Aryan Purandare? Hello?
Yes, sir.
What is meaning of electric dipole?
So electric dipole means two equal and opposite charges which are separated by a finite distance.
So because electric dipole is equal opposite charge, what is net charge inside the cube then?
0.
So what will be the flux then? 0.
0.
So I can say since electric dipole inside cube means two equal opposite charges inside cube. Two equal opposite charges inside cube. Therefore, net charge equal to 0. Therefore, by Gauss's theorem, flux is Q inside upon epsilon naught will be 0. Understood the second also? Answer? Hello?
Yes, sir.
Yeah, write down there. Sakshi, you are there? Sakshi? Hello, Sakshi?
Yeah, sir.
This all will be useful for your exam also, board exam.
Okay, sir.
So if second done, then tell, so that I can clear and start solving third one.
Done, sir.
So, what is flux due to electric field? What is flux means phi due to electric field E is 3 into 10 raised to 3, you know,
Yes, sir.
10 raised to 3 I cap Newton per coulomb through a square of side 10 centimeter. Square of side 10 centimeter. When it is held normal to it. Who is held normal to it?
Square.
So what is electric flux due to field E through a square of side 10 which is held normal to it? Flux is held normal to it. We have to find what will be the total EMF. Okay, this is a face of square. It is held normal to the field. So can I say flux is E bar dot area vector A bar by formula?
Yeah.
That is nothing but EA cos of 0 because area vector will be also in same direction. Not followed? Hello? Hello?
Yes, understood.
What area is nothing but side square, cos 0 is 1. So E is 3 into 10 raised to 3. This is 10 raised to minus 1 raised to 2. So 3 into 10 raised to 3 into 10 raised to minus 2 equals to 30 Newton upon Coulomb into meters. Where anybody who has not followed this flux? If charge is given, then charge upon epsilon. E value given, then E into area vector. E dot product. Everybody is cleared with this? हेलो मनस्वी,
Yes, sir.
इधर बार क्यों नहीं डाला? ये इधर फ्लक्स के ऊपर बार, फ्लक्स के ऊपर है
उसमें
बार.
नहीं डालते हैं ना.
हाँ, फ्लक्स स्केलर क्वांटिटी है
हाँ.
और एक डॉट प्रोडक्ट मतलब स्केलर क्वांटिटी होता है. करो फटाफट लिखो थर्ड. So now you should not lose even single mark in electrostatic board paper at least. When is your exam? 11th December, no? This DAV student will have exam when?
Yes.
तो तभी तक अपना एटलीस्ट इलेक्ट्रोमैग्नेटिज्म का मैं मैक्सिमम कर देता हूँ रिविजन. Once you are done, please tell so that I can clear this. Now 90% you should know. It should not happen कि कुछ आ ही नहीं रहा है. चलो डन.
Yes, sir.
Next sum, exactly same as fourth, similar to, not exactly same, is given even in state board book. Two charges of minus 2q plus q are located at point. Two charges are located at point A0 and 40. What is meaning of A0 and 4A0? It is x-axis or y-axis?
Excellent.
Two charges, minus 2q at A comma 0 and plus q at 4A comma 0. What is electric flux due to these charges through a sphere of radius 3a? Sphere of radius 3a, if I draw, will it enclose both the charge or it will enclose only the negative charge?
Only negative.
So can I say the sphere, after drawing the diagram, of radius 3a will only enclose charge minus 2q. Therefore, by Gauss's theorem, they want what is the flux through the sphere. So by Gauss's theorem, hello.
Yes, sir.
So by Gauss's theorem, flux equals to charge inside is 2q upon epsilon naught in inward direction because charge is negative. Okay. Hello. Not followed.
So could you explain the last bit?
अरे चार्ज इसका अंदर रहेगा वही देता है ना अपने को फ्लक्स है ना, इसका आउटवर्ड नहीं तो इनवर्ड है ना.
Okay, हाँ हाँ.
तो स्फीयर का रेडियस 3a, मतलब 4a वाला चार्ज इसका बाहर है तो ओनली इट विल एनक्लोज विद चार्ज माइनस 2q ना.
-2q, हाँ.
अगर ये q भी रहता अंदर तो नेट चार्ज एनक्लोज विल भी इसका मैग्नीट्यूड, मतलब मैं q लिखता था ऐसा. तो
Okay,
ओनली
sir, got it.
is inside, therefore 2q upon epsilon naught, but direction where inward. These are all just 1 mark questions, so short questions, but same they will convert in MCQ also now because pattern is slightly changed. First 20 question is MCQ. Chalo, can I clear this now? हो गया ना?
Yes.
Next one. A charge Q is placed at center of cube of side L. A charge Q is placed at the center of cube of side L. Electric flux passing through each phase. Total flux through entire cube is equals to q upon epsilon naught. How many phase the cube has?
6.
6. Therefore flux through one phase. अब ये entire cube का मतलब indirectly 6 phase है ना. So through one flux through one phase is 1/6 of q upon epsilon naught. Clear? Hello, is it clear now?
Yes, sir.
Yeah. Copy. Hello, can I clear now full? Fifth also?
Yes.
Sixth. Figure shows 3-point charges plus 2q minus q and 3q as shown. What is electric flux through the configuration through the surface S? Electric flux through surface S is equals to net charge enclosed upon epsilon naught. So plus 2q minus q upon epsilon naught. Q upon epsilon naught. Don't take 3q because it is outside. Yes, done. Okay. Now 2 marks question number 7. Given uniform electric field E, given uniform electric field E, which is 5 into 10 raised to 3 I cap, 10 raised to 3 I cap, Newton per coulomb. Find the flux of this field through a square of side 10 centimeter, square of side 10 centimeter, whose plane is parallel to YZ plane. That means if this is X, Y, Z, our square is having plane parallel to YZ plane, and field is in this direction because it is I cap, 5 into 10 raised to 3 I cap, acting along x-axis. What would be the flux through same square? So first find the flux if phase in YZ plane, and second one, if the same square makes angle 30° with x-axis, theta is 30° with x-axis. Just write this data and draw this diagram to make you understand. Yes, done.
Yes, sir. Done.
Now area vector is in this direction. So part 1, flux phi is E bar dot area vector A bar. So it is EA cos 0 because both are in same direction. So E into area A square cos 0 1. E is 5 into 10 raised to 3. Area is 10 raised to minus 1 side square. So this will be 5 into 10 raised to 3 into 10 raised to minus 2 equals to 50 Newton meter square per coulomb. Right, the first one, 50 Newton meter square per coulomb. Okay, over.
Yes, sir. Done.
Then they are telling plane is making 30° with x-axis. So you are not changing E. E is along x-axis only. That is E equals to 5 into 10 raised to 3 I cap along x. But this time it is not perpendicular to the plane because plane is making 30° with x-axis. So this is the plane making 30° with x-axis. ऐसा आएगा plane. Plane making 30° with x-axis. The plane is making 30° with x-axis. 30°. So area vector will make 60° with x-axis. Correct or not? Hello? Hello?
So how 60?
Area is perpendicular to the plane. So this plane is perpendicular. If I draw, अभी देखो 3D फिगर है तो ये x है, ये प्लेन सपोज एज्यूम किया 30, तो एरिया वेक्टर इसको परपेंडिकुलर होगा ना, ऐसा आउटवर्ड है ना.
Okay, okay, yeah, got it.
Got it?
Yes, sir.
So can I say flux is E bar dot A bar? That means देखो एकदम ही सिंपल है, अगर एकदम इजी बनाओ तो this is suppose plane and this is x axis making 30°. This is area vector, वो 60 बनाएगा ना.
हाँ सर.
अगर x axis के हिसाब से बनाया तो ऐसा, ये plane making 30° with x, but area is perpendicular to the plane, therefore it will make 60° with x. So can I say it is EA cos of 60?
Yeah, sir.
E is 5 into 10 raised to 3, area 10 raised to minus 1 raised to 2, cos 60 is half. So this will become 50 into half equals to 25 Newton meter square per coulomb. Solve. Done? Shall I clear now?
Yeah, sir.
Next question. Aryan, read. Next one.
Sami?
8 sum, read.
Given a uniform electric field, E is equal to 2 into 10 raised to 3 Newton per coulomb. Find the flux of
नहीं
this
नहीं नहीं
field.
नहीं, एक मिनट कौन सा रीड कर रहे हैं?
Rate.
आई कैप भी है ना आगे?
हाँ, sorry.
आई कैप न्यूटन पर कूलम. हाँ.
Find the flux of this field through a square of side 20 centimeter whose plane is parallel to the YZ plane. What would be the flux through the same square?
Plane is parallel to YZ plane. हाँ, आगे.
What would be the flux through the same square if plane makes an angle of 30 degree with the x-axis?
Is it similar to 7th only?
Yes, sir.
खाली वैल्यूज अलग दिया है ना, बाकी सेम है ना?
हाँ.
Try. All of you try and tell me the answer. See, no need to draw the diagram. वो तो मैंने आपको समझाने के लिए बोला था. YZ plane, it is perpendicular to x. मतलब अपना area vector will be along A bar. E is also along x axis only because it is I cap. So first flux will be E A cos 0. That is nothing but 2 into 10 raised to 3 into side square, which is 2 into 10 raised to minus 1 square. Cos 0 is 1. No, none of you got the answer. Ashwin, answer. Viti, what is the answer?
So 40 and 20.
No, first answer I got 80. Area is side square, na? Forty and 20.
Yeah. Sorry.
So I didn't get that.
1 minute. See, what is the value given? 2 into 10 raised to flux passing through square of side 20. Okay. 20 means 2 into 10 raised to minus 1 or not? Tell me in meter.
Yeah.
Area means side square, na?
Yeah.
So 2 square is 4 into 10 raised to minus 2. 80 you will get, na?
But then what about like cos theta?
Cos 0 is 1. This is cos 0 I have written. Cos 0. Because A bar and E bar is same angle.
Yeah, but wouldn't it be cos 30?
That is first part. Second part I am explaining.
Yeah. Okay,
Once you
okay.
get first, after the second will be EA cos 60, na? Flux in second part. See, make yourself comfortable first. First one you got 80. In second case they are telling plane is making 30 degree with x. That means if this is x, this is the plane, this is 30 degree. So in this direction we have got E bar, area of vector is perpendicular, na? So what will be this angle, 60 or not?
Yeah.
So flux will be E A cos 60. E is 2 into 10 raised to 3. Area is side square. 2 into 10 raised to minus 1 square. Cos 60 is half. Therefore, it will become 10 raised to 3 into 4 into 10 raised to minus 2 equals to 40 Newton meter square upon Coulomb. Okay.
Yes, sir.
Ninth one, see, is it same type again? Exactly same type?
Yes, sir.
Will you try this now? Try just now and tell the answer. तो तीन एक जैसा हो गया तो आपको समझ गया फिर कैसे. Swarno? Try ninth.
Sir, is it 4 and 2?
Ninth one, what you got first one?
4.
425 9 हाँ एक मिनट.
Sir, 1500.
हाँ 10 का मल्टीपल में होएगा ना. 5 square 25 है ना.
10 and 5.
See, it is 4 into 10 raised to 3. So first one, when plane is square is in YZ plane, that means it is perpendicular to X. So flux will be E A cos 0. E is 4 into 10 raised to कितना है 3 है ना. 3. And
Yes, sir.
area means side square. Side is 5 centimeter. Square of 5 into 10 raised to minus 2 square. So it is 5 in 4 into 10 raised to 3, 25 into 10 raised to minus 4, 100 into 10 raised to minus 1. 10 आया. 10 meter square per coulomb. And second case, it will be making 30 degrees. So EA cos 60. EA already we got answer. Directly also you can put if you want. 4 into 10 raised to 3, 5 into 10 raised to minus 2 into half. तो क्लियर कट दिख रहा है 5 आ जाएगा ना. 4 into 10 raised to 3, 25 into 10 raised to minus 4 into half. So 2, 50 into 10 raised to minus 1, 5 Newton meter square. Only important was angle is not 30, 60 between E and A. Yes, you all got now?
Yes.
Yes, sir.
10. So a sphere S1 of radius R1. A sphere S1 of radius R1 encloses a net charge Q if there is concentric sphere of radius R2 such that R2 is greater than R1, enclosing charge 2Q. Find the ratio of flux through S1 to that through S2. How the electric flux through sphere S1 change if medium of dielectric constant K is introduced inside S2 in place of air. How this S1 will change if we have here medium of dielectric constant K. other than air. First, read the question. See, everybody has understood meaning of the sum. We want ratio of flux through S1 and S2. Question followed. So now,
Yes, sir.
what is charge inside S1?
Q.
Q. So flux क्या होता है? Charge enclosed upon epsilon ना, अगर air होता है तो.
Yes, sir.
So can I say flux through S1 is charge inside upon epsilon naught. कौन सा rocket science है इसमें? So flux through S1 is Q upon pi 2. What will be flux through S2? इतना डर कैसा 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 आंसर फटाफट बोलो ना क्या है. What is net charge enclosed by S2? It is 2Q plus Q or not?
PQ.
हाँ. So 3Q upon epsilon naught. ये second आया, ये first आया. So ratio of flux through first one to that of second will be equals to Q upon epsilon naught into epsilon naught upon 3Q. Is it 1 by 3 then?
Yes, sir.
हाँ, तो एक पार्ट हो गया. अभी क्या बोल रहे हो लोग? इसके बीच में हम लोग ने एक डाइलेक्ट्रिक डाला K वाला, तो इसका फ्लक्स को कुछ चेंज होएगा क्या? कुछ नहीं चेंज होएगा, उसका चार्ज तो एयर में ही है ना.
हाँ सर.
नहीं, अभी 2Q वाले चार्ज का क्या होएगा? वो 2Q अपॉन K एप्सिलॉन नॉट जीरो फ्लक्स देगा प्लस Q अपॉन एप्सिलॉन नॉट देगा, क्योंकि नेट चार्ज सब एयर में नहीं है, लेकिन S1 का तो सब चार्ज अंदर ही है ना, उसमें थोड़ी डाइलेक्ट्रिक डाला हम लोग ने. तो आई विल से द बाय पुटिंग डाइलेक्ट्रिक बिटवीन S1 एंड S2 देयर विल बी नो चेंज इन फ्लक्स ऑफ S1, क्योंकि उसका चार्ज तो अभी भी एयर में ही है ना. हेलो.
हाँ सर.
Okay, please write this one, then that argument we are doing. If completed till then the wording I am telling. Arya, any doubt, Arya?
No, sir.
Yes, yes. All sums do carefully, because this itself is your MCQ based question. Okay, done. Hello.
Yes, sir. Done.
Right. By putting dielectric inside sphere S2, by putting dielectric inside sphere S2, by putting dielectric inside sphere S2, charge inside S1 still remains in air. Charge inside S1 still remains in air. Hence, charge inside sphere S1 still remains in air. Hence, there is no change in flux through S1. Hence, there is no change in flux through S1. Hence, there is no change in flux through S1. Okay, 11th one. A thin, straight, infinitely long conductor. Thin, straight, infinitely long conductor having linear charge density lambda is enclosed by cylindrical surface of radius small r, length L, axis coinciding with the length of wire. मतलब ऐसा है ना वो cylinder, radius is r, axis is coinciding with length of wire. Find the expression. Okay, find the expression for electric flux through the surface of cylinder. मतलब इधर से हमको फ्लक्स चाहिए. फ्लक्स के लिए क्या लगता है? Charge enclosed. Very good. What is meaning of lambda? It is charge per unit length, na?
Length.
So can I say charge enclosed by cylinder comma q equals to lambda into length, correct? No?
Yes.
Now by Gauss's theorem, flux is q inside upon epsilon naught. हो गया lambda L upon epsilon naught. Anybody is having doubt to understand this? Hello?
No, sir.
Yeah, please copy then if you have understood properly. Done now. I think it's very simple. Completed? Hello?
Completed, sir.
One second, sir.
Okay.
Done, sir.
12. Show that electric field at the surface of charged conductor is given by, show that electric field E is given by sigma epsilon naught into n cap, means perpendicular, where sigma is surface charge density, n cap is unit vector normal to the surface in the outward direction. If charge is positive, it will be in outward direction on the surface of conductor. The conductor means you can take any shape. I am taking spherical shape because that will be best to understand. Consider a spherical conductor. Let lambda be charge distributed on that surface, or sorry, delta be charge per unit area on the surface. Consider elemental area dA. Now intensity consider a spherical conductor with center or radius r to be charged uniformly with positive charge having surface charge density sigma. Let P be a point at a distance small r near the conductor. Draw a Gaussian sphere with center or radius r. It will pass through point P. Intensity at point P is directed normally outward. Let Ts bar be the elemental area of Gaussian sphere. Now by Gauss's theorem, flux is Q inside upon epsilon naught. Therefore, E bar dot ds bar over closed surface is also flux will become Q inside upon epsilon naught. Please draw this diagram. Draw diagram, then I am writing. Yes, completed.
Yes, sir.
Diagram part I am rubbing. Huh? And that writing part also you have done.
Yes, sir.
Below that, write down, draw Gaussian sphere with center O, radius R. Draw Gaussian sphere with center O, radius R. Therefore, by Gauss's theorem. Then write full. This will be E T S cos 0 because E and ds are in same direction equals to Q inside. Q inside is sigma into 4 pi R square upon epsilon naught. See, sigma is charge upon area. Area is 4 pi capital R square on this charge is distributed. Therefore, it is written this way. Please stop. Wait 1 minute. This Q ka formula you all followed. Sigma is charge upon area of the sphere whose radius is R. So sigma is Q upon 4 pi R square.
Yes.
Now, if you take integration of Gaussian surface complete, it will become total area 4 pi small r square.
Yes, sir.
So we get E into total area 4 pi r square is sigma 4 pi capital R square upon epsilon naught. 4 pi cancel. E is sigma r square upon epsilon naught into small r square. But point is just outside. Therefore, R is same as capital R. So, E is sigma capital R square epsilon small r square will become capital will get cancelled. Sigma upon epsilon. Copy now. So, yes, completed full.
Yes, sir. Done.
Next one, 13. a spherical conducting shell of inner radius R1 and outer radius R2. A shell, inner radius R1, outer radius R2, has a charge Q. Outer radius R2 has charge Q. A charge small q is placed at the center of shell. What is surface charge density on inner surface and second outer surface of shell? Then write expression for electric field at a point where x is greater than R2. That means point P lies outside from the center of shell. See the question. The shell is having charge Q. Charge Q distributed on the outer surface. But inner surface का center पे there is Q. Hello? Hello?
Yes, sir.
Charge always resides on outer surface ना, तो ये charge Q है surface पे. लेकिन वो लोग ने क्या बोला है, प्लस Q एक अंदर रख दिया सेंटर पे. So due to this plus Q, इसको अंदर इंडक्शन इफेक्ट मिलेगा ना माइनस Q, बराबर.
हाँ सर.
ये मटेरियल है ना, शेल मतलब थोड़ा जाड़ा रहता है ना, ये मटेरियल है, डाइलेक्ट्रिक नहीं है. एक शेल है ऐसा, तो ये तो पूरा मटेरियल है ना इधर, और अंदर हॉलो है ना. हेलो.
हाँ सर.
Will there be any electric field inside here? Inside the metal, electric field passes or not? What is property of line of force? It can pass through insulator but not through conductor. Hello?
Yeah, sir.
That means there should be no field inside. When it is possible? When net charge inside is zero, na?
Yeah.
So this minus Q will induce charge plus Q here, so that अंदर कुछ भी field नहीं होएगा. Hello?
Okay, sir.
So net charge on the outer surface will become how much? Q plus Q. This Q plus this Q is also there, na?
हाँ सर.
तो अभी इसका ऐसा क्वेश्चन हो गया. We want what is the surface charge density of inner surface. Inner मतलब ये inner surface का surface charge density. Charge density on inner surface is due to negative induced charge. So therefore phi 1, that is inner surface, phi 1 charge on that surface is minus Q upon area 4 pi R1 square. First part over. Then charge density on outer surface is due to Q plus Q. So sigma 2 is Q plus Q upon 4 pi R2 square. Write this too. Complete. This was a bit difficult. First time this center wala charge ka effect we have to consider. Completed. One more part is left out. Electric field at a point P which is outside and at very large distance. Yes, done. Hello.
Yeah, sir, done.
Okay. Whenever point is very far, whenever point is at very large distance, that is x is very large than r, then charge on outer surface is considered as charge concentrated at center. जब एकदम दूर से जाएंगे तो स्फीयर बहुत छोटा हो जाएगा, so entire charge will become central charge. So therefore E will be K total charge Q plus Q upon distance square, which is same as 1 upon 4 pi epsilon naught charge upon distance square. हो गया ये आंसर. But I have not sent you the question of this now. How you are writing? Nobody is saying also anything. What people are doing, I don't understand. This question I have sent, which I am talking about. Huh?
No, sir.
So you are not telling also anything. That shows that nobody is interested in anything. Just teacher is telling something, you are hearing something, writing something without knowing what you are doing. If this is your approach, then I will give you just test. Keep on writing the test. And don't score any mark. Now, second page also I have sent. Go through it. Friday again, I will be doing same topic ahead. So our first chapter will get totally completed. Sunday you will write test, but I will discuss the timing with you all, so that you are keeping your video on and writing the test. I will be observing. That's all. We'll meet on Friday. Please revise all